Hey everyone, I'm gonna move into the second coding exercise. In our previous video, we went over dot products, how to code it. Just as the same in the previous video. I'm gonna try and focus on, showcasing my thought process in terms of how do you learn things, especially as we move on. Trying to go out of your way, try and learn a little bit more than you really need to for the task at hand. It's always a good quality and it'll always help you learn things even better. Remember to learn by doing, try and learn more than you need to, and try to, teach it to other people. Yeah, this is the approach in general. One thing I wanted to bring up that I had missed in my previous video that I wanted to speak about was regarding dot product. So when I was going down the initial rabbit hole of dot product stuff, not this is like the tab group I had. One of my weird initial things that is really, really stupid, but I am open to admitting it. So I thought dot products and matrix multiplication were actually pretty much the same operation, but they're clearly, which honestly, in retrospect, makes complete sense that they're not, because matrix multiplication, you multiply each row with each column um, to actually get the outcome, right? Um, and when I went into that, I was just like, okay, wait, dot products are not the same as a matrix multiplication? How come? And then I Googled it, came up with this little summary that Gemini generated for me, and then I went straight to this mathematics stack exchange, where this guy actually put it very succinctly. C such that if the Cij entry of a matrix, C such that AB one takes the dot product of the ith row of the matrix A with the jth column of the matrix B. So they are related in the sense that matrix multiplication yields a new matrix, and the matrix is formed by the dot products of the rows of the first matrix and the columns of the second matrix. Which I know it was dumb to not realize this, but still, it was a little point that I just wanted to put out there. In terms of actually looking these things up yourself. It's just a thought process of just going wild. I had gone really wild here. I was just looking at lots of different things. How to write appropriate error messages, something I didn't showcase in the previous video, but I also wanted to, you know, raise a value error if the vector shapes don't vector sizes were not the same. I didn't do that in that video. I might do that in this video. I don't remember this is the pylans, just looking into pylans, looking into the numpy dot um, what's the word I'm looking for, documentation. These are the kinds of things you want to fall down rabbit holes. You really do. That's really how things cement in, or at least that's how they start. To really cement it, you have to actually do it. You have to play with it, and you have to come back to it again and again over time. Maybe use mnemonics, whatever. These are the kinds of things you want to be doing. So I'm just going to move into the matrix multiplication task, which is somewhere. I'm just gonna open up a new tab really quickly and pull it up. It's basically the same as the previous one, uh, which was essentially just do the matrix multiplication. There was an additional thing of verifying your result and using the classic three nested loop algorithm. So initially I worked on just doing the two-dimensional matrices. So I'll build upon that right now. Let me just open up VS Code real quickly. Okay, so VS Code is open. I'm going to open the directory I've been using for doing these tests, for doing these videos, which is, I think it's DS Math. Yeah, it's DS Math. Open. I'm gonna just continue on from the previous video here, because the way I had done it was actually using the dot product function itself. So let's just start with def map mul. Okay, I'm just gonna go a comma b. we'll just use capital A and capital B to signify that they are matrices, right? Now, for a matrix multiplication to be valid, it needs to, the columns of A uh, need to be the same as the rows of B. I actually had it the other way around when I initially did it. And I went down another rabbit hole being like, wait, isn't it supposed to be that the rows of the first one matches the columns of the second one? Which makes intuitive sense because you multiply the row of A with the columns of B, right, to get each individual value. But no, it's the other way around. It's somewhere in one of these mess of tabs where I went down this rabbit hole, but it's an important one to just keep in mind. So the way it's generally put, I'm just going to put a comment here and write it out. Let me just hit pass so that it stops complaining. Is that basically for matrix A and B, A needs to have shape M by N, and B needs to have shape N by P. Let's say P, because that's a common one, right? So that's generally how it does. So what are we going to do? We want M, which is the len of A, right? Of A, right? Now n is the n is kind of a weird one, right? Because this is where you need to raise potentially a value error. You might want to raise an error, so I'm just going to do that here. Once again, we're just trying to make things a little bit harder for ourselves as well, go out of our way, learn some new things, right? So how do we do that? Okay, so I'm going to just write it as a separate function. So def j underscore val, because I comma j, I and j are common ways to denote indices in a two-dimensional matrix. So I just j val is like column validation or whatever. So I'm just gonna call it that. Def j val gets a gets a matrix colon, right? Now we have to make sure that each of these are the same, in the sense that each row has the same length, right? So I think what it is should be, I forget exactly how I did it because I did I've already completed this in a separate exercise over here. What do I want to do? This is a good question. What do I want to do here? So I want to go through each row in math. Alright, so let's see if we can use the Walrus operator. J colon equals len v for v in mat, right? Wait. So actually, no, I don't want to do that. I need to make sure that it's validated and it returns the value. So actually, yes, I do want to do this. I'm gonna set this as a list. Honestly, I could do a generator expression as well, but I'm just gonna do it as a list because I am forgetting the pitfalls there. So let's see. So j colon equals, so we're using the Walrus operator here so that at the end we can just return j without having to calculate len v again. So this is a list, so I want to have turn this into a set, right? And okay, so a set will be all unique values, right? So if len set not equals 1, if len set not equals 1, raise value error, rows need to be of same length. Okay, let's say that. return j. I believe that should work. Type of parameter mat is not set. I honestly didn't go as deep into doing the type hinting when I did this myself, but we might do this as this video progresses. So we might not. I don't know. I have a time block to make these, so maybe I won't. Let us see. So okay, we need J. Let's just just to make sure we're going on the right path. Let's let's just go print j underscore val a. Let's just keep that as the only output right now. Argument type is unknown. Okay, Pylance just keeps complaining. I'm gonna copy some of the. I don't want to look at the code. We'll get to that later. We're just gonna boom over here, and nope, not that. Over here. I'm just gonna copy some of these test cases I had from earlier. Just gonna print these. The map null is not defined. Makes sense because I didn't run this. Let's run that cell. Now we're running this cell. 2, 3, 3. So yeah, okay. I seem to be getting the correct answer here. There's two columns. So okay, so that is working. So we want n equals j, but we also need to think about this for a moment, right? Because we need the columns of matrix A to match the rows of matrix B, right? So we could do this potentially once again using the walrus operator, and I'll be honest, I went through a little bit of googling on the walrus operator as well, and I made a mistake that I will just demonstrate right now. So if n colon equals j underscore val a, oops, not what I meant to do. Jval not equals len of b, right? You're gonna want to raise a value. I'm not sure if value error is the right exception to raise. That's another rabbit hole that I will probably fall into after I'm done making this video. But for the purposes of this video, we're just gonna raise a value error and say that the shapes don't match. Don't match. I'm just gonna do that because I can't be bothered to switch from single to double quotes. Right? So shapes don't match. You can make this even more. If you are trying to be fancy, you could be something like, you could turn this into an F string. That's not exactly something I need to go down a rabbit hole for. Columns of a, and you could set over here j underscore val a, something like that, right? Actually, you would set n, right? Because we use the walrus operator, so we can just use n. And then rows of b, len b, because we did not use a walrus operator there, so we're just gonna have to calculate it again. Now, some of you may have already picked up on this, but if you haven't, there is a mistake here because, and this is a mistake I made and it took me a while to debug. I'm just gonna give it to you, though. Honestly, if you make this mistake and go down this rabbit hole, you're just gonna learn more. So that's awesome. Here, the mistake I made is when I use n colon equals and do this, what I'm actually doing is I'm actually assigning n to this, right? And that caused a couple of problems for me when I was doing this, specifically when I did the implementation with the classic 3 nested loop algorithm, which I'm not going to do right now, but I will, or maybe I will. I don't know. Let's see how the night goes. Who knows? Let's get crazy. You know, we'll drink a Diet Coke. We'll have some fun. Right. So if you really want n to be assigned to j val a, what you're really gonna want to do is wrap these in parentheses. So now n is assigned to this, and then the actual expression is checking n versus len b. Okay. So now we have n assigned, and p is easy. P is just j underscore val b. There you go. Okay, so we have our m, our n, and our p. Right? We actually don't need to do MNP the way I did this initially. So I'm just going to show you case that. But it becomes handy for the classic 3 nested loop algorithm, which we'll get into later. So let me just clear up these random comments. Also, I'm just going to go ahead and change my settings on Pylance, because I'm getting a little annoyed by the squiggly lines, and I know they don't really matter right now. But it is one of those things, like, you know, keep them on, you know, so that you know, like, best practices that you could be changing on. So I basically go, let's say C, let's just call it mat equals an empty list, right? Okay, so because we realized that essentially getting the vectors, that doing a matrix multiplication is just a series of dot products, right? So how I did this was I just set an empty list mat, as I already have, and then go for, what do I do? For vec and, let's just say vec A in A, right? So for each row in A, okay, so this is where we fit another roadblock if we just want to reuse the function which we already have of the dot prod, which is what I was trying to do initially. We're gonna need a way of getting the actual vector, right? So to get the vector j, which is the column in B, we're gonna use enumerate A, and let's say idx comma vec A, right? We need to get the vector j, right? So let's just split that out into another function. J underscore vec, it takes idx and takes some matrix, right? And what do we want to return? We want to return, let's say if I can do this in one shot. Return x idx for x in mat, or actually let's just use v for vector, because, you know, consistency or whatever. Return v idx for v in mat. Is this correct? Let me think about this. I think so, because we're going over each row in that matrix, and we're getting the value from that idx, which we're getting from here. So the first row will go with the first column, the second row will go with the second column, the third row will go with the third column, right? So we want to take the index here, or idx as I'm saying it, which I'm getting from the enumerate function, and popping it in here. So I'm going over each row in matrix B, getting that value and creating a new list, which I'm returning. I believe that is all I need to do. I'm just gonna go back and check my old stuff to see if that's accurate. Yeah, okay, it is. Let's just go on with that. I was just overthinking that for a moment. Okay, so now that I have, okay, so now in this loop, what do I have, right? I'm getting the JVec, right? And I need to get the dot product, right? And I need to append that here. So I need to append that to this, and I need to do that for each column in matrix B, and then that will be the first row of the final matrix, right? Right? Because the matrix multiplication is row times column, right? So actually, maybe I don't need the enumerate. Actually, don't think I do. So I'm just gonna remove that. Let's hope I actually don't need it, so I don't have to like rewrite it or something. Well, I would just use undo and put it back that way. How do we do this? How do we do this? So we want to do for idx in range P. Is that correct? Right? P is the number of columns in matrix B. Yeah? Yeah. So then we had, and then we get mat.append np, oh, not np, mat.append dot prod. Wait, that doesn't seem right. Oh, I need another list. Okay, so row equals, I need another empty list here. Sorry, row.append.prod. Okay, that makes sense. I was being a little silly over there. Vec underscore a. No, wait. Yes, vec underscore a, comma, j underscore vec idx, oops, idx comma b. Right. So for each row in A, we go through all the columns in B, we do a dot product, and we append it to row. So once we exit the second loop, we would do mat.append row, right? Yeah, that seems about right. And then we return mat. I think we can remove the pass so that, and I think this is correct. Now, ideally, I'm just like doing this somewhat from memory. If I was you and you're working on this yourself, I'm like just like kind of going. I'm like, oh, I did this that previous time, right? And I'm just kind of doing it off memory. I would like go ahead and just, you know, even if you want to use your classic good old fashioned print statements at every line of code you're writing, just to make sure you're getting the right thing, right? So I believe that should work. Let us confirm that. We have these test cases here, and we have the expected answers, and boom. So for the first one, it's 1922, 4350, 68, 12, 1, 102, 010, and 0300. Yep. So we've gotten that correct. But we're not done, because this is where the fun stuff begins. If you remember here, verify your result against npMapMul. I'm not going to do that, though you should, honestly, if you're doing this at home, and you should also spend the time to actually look up the MapMul documentation. I've done it. I also went through the Wikipedia. Just, you know, fall down some rabbit holes, man. Have fun. It's always fun to fall down some rabbit holes. Why did I pull this up? Errors and exceptions. Oh, I remember why I did this, because I wanted to raise a value error in a weird way. Never mind, it doesn't matter. But okay, the thing is, here they very clearly state implement the classic 3-nested loop algorithm to compute AXB. Now, let me see if I can find it. Was it here? It might have been this one. Yeah, I had it describe the nested loop algorithm, and then I uploaded my response, and it said that no, that is not the classic nested loop algorithm. And I just asked for this code, which I skimmed really quickly, and I'm not gonna show you the code really quickly. It's an exercise, you know, for you to do at home, or I mean, you know what? I'm feeling frisky. Why not? I went through, I had skimmed the code super quickly when I did this myself, like, but I tried to get some distance between myself. Like, I skimmed the code and then I came back to it the next day. Then I just looked at the top summary and I just tried to think it out as to how to do it because I had a vague memory of how the code looked like. And I was like a bit struggling, at which point, take it slow, go analog. And what I ended up doing was actually writing it out. Okay, that's a different thing. Don't focus on my personal branding notes. I write random shit sometimes. I got a lot of stuff here. Don't, let's actually, can I hide this? No, I cannot. So, I can hide that, but I can't hide my notes. Well, it's going in the notes. If you guys want to see the titles on my notes, I owe my dad some money. You can see that in that note over there. So I just like wrote out like some examples, right? The MNP thing that I was just describing a little bit earlier. Here, I just wrote up a random 5 by 3 and a 3 by 4 matrix because this would be a valid matrix multiplication because this one has three columns and this one has 3 rows. Remember we discussed this, right? And the output would be a 5 by 4 matrix. And what I realized was like because the output matrix, so the other thing I realized is the output matrix, just as much the matrix for the matrix multiplication to be valid, m by n and n by p, your output matrix will be m by p, right? So I just named all of these with the indices and all of that, and I just wrote out a few dot products, like what would M1P1 be, right? M1P1 will be M1N1 times N1P1 plus M1N2 times N2P1 plus M1N3 times N3P1, right? And same again a couple of times, wrote a generalization of that. I just started thinking about it, right? Because from what I remember skimming of the thing, it was using the increment operator, which actually made me go down another rabbit hole. Let me see if I can find it. I had like a thing about increment operators here, about whether so Python doesn't have a post decrement and post or pre increment or decrement operators the way like C and C++ did, which I remembered from a long time ago. So I was just like looking at that. Um, and also going back to the walrus operator, let me see if I can find this. It's like interesting because the walrus operator is doing something that like is already true in other languages, like specifically, you know, that a assignment is also a statement, I believe is the correct word. Uh, Let me see if I can find line one shows uh, during earlier stages of the wall. You may also see colon you add another term used for assignment expressions as named expressions. Oh, maybe this isn't it. So yeah, there you go. Motivation. This is the thing I was looking for. Essentially, because, assignment is also um, expressions, right? And that's where the walrus operator comes in, is where you can do the assignment and also evaluate it as an expression, something that is already supported in like C, as you can see here. This is C code over here. Yeah, anyways, the more you learn, it's kind of interesting. I fell down this rabbit hole. It's kind of unnecessary to the whole video to talk about it, but it's fun. That's the whole point. You learn things, you do them, you learn more, you show it to others, um, and it's just like a constantly expanding sphere. So it's honestly beautiful. It's an amazing thing. It's an amazing feeling as well. Um, how did I get down this rabbit hole in the middle of this video that I'm trying to make here? I was trying to talk about, oh yeah, the thing. So I remember vaguely from the code snippet when I was writing this, I mean, not right now, But when I was writing, I was vaguely remember. It's like, okay, I remember they went through looping through each one, uh, for each of the rows in A, for each of the rows in B, and then for each of the columns in B, and doing an increment to the different indices. And I was like a little bit confused as to like how that was working. So I had to think it out, right? So I knew that this was the assignment operator essentially, and I know that the output matrix has to have the shape m times p, right? And I'm like doing something like this, right? It took me actually like quite a few minutes to like write this part out and be like, okay, is this correct? I was thinking about it, and then I'm like, okay, let me just actually write it out. And okay, I did some pseudocode here to showcase how it would look like, and then I'm like, okay, but is this correct? So I just did the iterations in my mind. Okay, iteration one, you're going through m1 p1, right? M, n, and p will all be 1, and you add m1 n1 times n1 p1 to that value, to m1 p1 in the resultant matrix. Iteration 2, you do the same with m1 p2, m1 n1, n1 p2, right? I'm like, okay, let me just go through the entire iteration of loop p, which gets us to m1 p4, m1 n1 times n1 p4. So I just, at this point, before I continued writing, I went up and I double checked, like, okay, does that make sense? Okay, m1 p1, m1 n1, n1 p1 gets added to m1 p1. Okay, so far so good. All right, we go through the second iteration. We just went dot dot dot, went to the end of the third nested loop, started the second iteration where now n has been incremented, right? N, right? Because there's 3 loops, m, n, and p. Once n is incremented, it's m1 p1 plus equals m1 n2 n2 p1 m1 p2 plus equals m1 n2 n2 p2. Yeah, makes sense so far. Okay, stopped once again, went back and checked. Okay, I am actually adding m1 n2 n2 p1 to this. Okay, that makes sense. Okay, cool. And then it's like m1 p4 plus so I did that one more time, double checked. I'm like, oh, okay, yeah, that matches with m1 p1 and m1 p2. Like, by the end of this, I get m1 p1 and m1 p2 correct. And then when we iterate again, we start with m2 p1. So I'm like, okay, this seems to make sense. Let's do this, right? So here, I'm just going to do def classic matmul. Let's just call it that. A comma B. I'm just going to copy paste a little bit of code from here. Honestly, just use this because that is accurate so far, right? And now the changes start happening, right? So here, where we just initialize an empty list, we're actually just gonna go ahead and get a list, a pre-initialized matrix of the shape that we actually want to return. So we want to return 0 for underscore and let's say range p for underscore in range m, right? Because the inner loop is like the columns, right? The number of elements for each row, and the outer loop is the range of m. I'm just range of m. I'm just repeating what it says. Maybe I'm a little bit tired. I'm sorry, guys. The outer loop is the number of rows, right? So, okay, we have our predefined list. Let's start the loop, right? We just wrote it out, so it's just a matter of doing that. It's not too bad. So for, let's say for a in range m, right? For, well, I'm just gonna call it midx in range m, okay, for n underscore idx in range n. And this actually is right here. I'm just gonna pause real quick. Remember how I was saying earlier, oh, I had hell with this and you didn't really need to do it for the previous implementation, but you do need to do it here. Because this is where I decided to do the use the walrus operator, and like, you know, I was not entering into the second loop at all, and I was like losing my mind. What is going on? And that's when I realized that I was actually assigning this entire expression, which is a boolean, to n instead of jval a. So anyways, just catching myself before I do it again. So for p underscore idx in range p, right? Colon, right? Okay. We do mat m idx p underscore idx equals, oh wait, not equals, plus equals. Don't want to make that mistake. Plus equals a m idx n idx times b n idx p idx, right? Right? Yeah. That seems right. Okay. And then we return mat. Okay. Let's double check the classic matmul. We're just gonna copy these over here, and we're just gonna use the classic matmul function to evaluate these. Let's see if we get the same answers. And there's an error, oh, because it's not defined, so we gotta rerun that cell. And voila, we have the correct answer again. 1922, 4350, 68, 12, 1, 102, 010, 300, which are all correct. I should have gone ahead and done assert statements like I did before that I shown you. That would have been nice. Just copying and pasting from what I did earlier here. So this is everything, honestly. I hope I'm not just showcasing how to do things and what to do, but also, you know, showcasing the thinking that went behind some of this stuff. Yeah, this is, I think, yeah, this is the Stack Overflow where I realized my mistake with the assignment operator, because here, see, is not none, and then you gotta change that. And he was talking also about the Pythonic way of doing things, so that's fun. And NumPy add operator, so apparently in NumPy, if you're using two NumPy arrays, you can use just like literally the at the rate of sign to matrix multiply them. And then I just remember what broadcasting was, so I was just like looking up what broadcasting was, which is basically element-wise operations between mismatched matrices, as long as there's compatibility, and how to do it efficiently. It was just kind of an interesting thing to go down. Hopefully my next video, I'm just going to do the Euclidean norms, and I was fairly good about organizing my tabs so I can actually try and walk you through the rabbit hole I was going through and try and showcase to you guys, you know, what you should be asking. You know, don't take anything at face value. Always be looking to ask questions, right? That's where it starts, that curiosity, that awareness. Because it's genuinely awesome. That's I think the number one thing to learn is actually fostering that curiosity and always asking questions, right? The everything else past that is all things that help cement it in your mind, but it's not necessarily the actual spark that gets you on that journey, right? So have a wonderful one. Hopefully you guys enjoyed this video. I'll try to see you guys tomorrow. I want to do these daily, but whether or not I will, still up in the air. Let's see. Have fun, everyone. Bye-bye.